In this video, we're going to look at current in a parallel circuit. This is the Microtrainer, a board I created to help people learn about electrical systems. And in our parallel circuit section, I've made a modification to the board. So unless you want to destroy your board, this video will be a good way to be able to help understand current and how it travels in a circuit. So what I've done is I've exposed the copper right here, and then I've cut the trace right here. So there's no longer a continuous path between this point here and this point here. We can see that if I turn this, so the board is on, and I'm not getting any illumination. I made this little jumper just to be able to show you. So if I go from here to here, so I can jump and turn that branch on, and I can jump and turn that branch on individually. This will help us to understand or see the current flowing in the circuit. So I had to break that in order to make it work. To make these measurements, we're going to use this Fluke 15B+. Really any multimeter that can read DC amps will work. So I'm putting my multimeter here on DC amps. If your meter doesn't show DC right here, there might be a button or some other mechanism to change it. So that's alternating current and that's direct current. So I want DC. I'm actually going to go to DC milliamps because there's not a lot of current going through here. And then as a reminder, you need to move your multimeter leads to match what you're trying to measure. So I'm in common with the black, and then over here I'm measuring over here the milliamps. The microamps is that weird looking U thing. Okay, so I'm going to put my multimeter back in the screen so we can see this in action. And as a reminder, current needs to flow through the multimeter. And so when I'm measuring current, I need it to go up through one of my leads and through the multimeter's fuse and then back down through the other leads. So we're going to measure in series. And when I make this measurement, I'm going to put my red meter lead here. It's best to put it closest to the battery positive, and then I'm going to put my black meter lead right here. So the first thing that you should notice is that light turns on. So that's an indication I have current flowing through the circuit, but only the bottom one turns on because I've cut the path going up here. So if I measure this, I have approximately 3.2 milliamps of current going through this bottom circuit. Now this is the resistor and this resistor are the exact same value, and this LED and this LED are the exact same value. Because I'm starting off with 5 volts, and both of these branches should have 5 volts, I would expect my upper branch, because the resistance is the same, to have that same value. So 3.2 here, and 3.2 for that branch. So this measurement shows us that 3.2 milliamps of current is passing through this branch, and 3.2 milliamps of current is passing through this branch. So I've replaced that parallel circuit board that I had cut the traces with this one that is currently functioning. So in order to measure the current here, I'm going to turn the circuit to the off position. So now I have an open between battery positive and right here on this branch. So if I wanted to measure the current, I'm going to make sure my meter's in the same condition. I'm going to put my red multimeter lead here on the B positive. And then if I place it right here on the bottom branch, we see we have about 6.5 milliamps. If I place it here on the top, we have about 6.5 milliamps. So this is a slightly different board, and the voltage might be slightly different, but we can see that added up, right? We had 3.2 here and 3.2 here. We add the current up for the bottom branch and the top branch, and that's the total circuit current. So the important lesson here is that the current splits in the different branches. If I had an additional branch here, I would split the current again. But the current splits, and that split is determined by the resistance of that branch. The battery voltage in this case is going to stay about the same at 5 volts because the resistances are the same on this. That's why we see a split in the current. So this bottom branch is 3.2. The top branch is 3.2. That means that 6.4 milliamps of current flows from the battery positive to right before this switch, and then we split the current up, and that split is happening because the current splits based on the resistance in the circuit.